Since the dawn of humankind, we have shared a deep communion with the stars. The universe around us inspires many of our most powerful beliefs about who we are and where we come from. On our journey of cosmic discovery, there have always been sacred places where we go to connect with the heavens. Places that help us make sense of all the wonders we see when we look to the skies above. Much of what we know about our universe comes from large optical telescopes, which capture visible light just as our eyes do. Like our eyes, these telescopes can only see the stars at night. Dawn brings an end to observations and to this optical astronomer's workday. But there are other telescopes built on a more massive scale that work around the clock, gathering invisible light from space. The Carl G. Jansky Very Large Array. This vast collection of dishes is among the most accomplished telescopes in history and one of the most recognizable.
These radio telescopes, rising like giant flowers from the New Mexico desert, are monuments to human ingenuity.
How are you going to convince your people to allow Americans to go on the flight?
We are going to get there first, and you have the knowledge.
The heavens and the earth.
Data transfer complete. Connor, we're joining you topside.
I think it's because we're looking for the meaning. Well, what is the meaning? We have mindless jobs. We take frantic vacations, deficit finance trips to the mall to buy more things that we think are going to fill these holes in our lives.
But beyond its fame as a scientific landmark and backdrop for talented actors, the VLA is the foremost astronomical instrument of its kind, attracting hundreds of astronomers performing cutting-edge science.
My name is Amy Rhines. I'm 36 years old, and I'm an astronomer. Every time I come out here, I'm surprised at the effect that it has on me. You're sort of out in the middle of nowhere, yet there's this contrast with all the technology, with these amazing dishes and all the work that goes into making the science happen.
Are you Amy? I'm Gene. Are you ready to go up on the antenna?
I'm fascinated by the early stages of galaxy evolution, back when the universe was in its infancy. And I just want to know, where does it all come from? How does it all work? And what's our place? It's hard to study these early galaxies because they're so far away. By studying dwarf galaxies today, we hope to try to gain insight into the formation of the first massive black holes. And this is the kind of work that would not have been done previously and cannot be done with any other instrument on Earth. It's just incredible to be out here.
It's pretty cool, huh?
Set within the natural beauty of an ancient lakebed, these dishes tower like sentinels over the desert floor. The Very Large Array didn't get its name by accident. Each of its antennas stands 94 feet tall, with dishes stretching 25 meters or 82 feet in diameter. They are spread across the desert in a Y pattern, up to 13 miles in each direction. Combined, They form a single giant telescope larger than all of New York City. This massive synchronized system monitors the cosmos day and night. The VLA's enormous size is necessary for the unique kind of light that it observes. Our eyes see only a small sliver of the light that reaches us from space. But objects throughout the universe emit light across the entire electromagnetic spectrum. At the long wavelength end of the spectrum is radio light. Because its wavelengths are so long, making sharp pictures from radio light requires a telescope that is miles wide. This invisible light reveals the birth of stars, the secrets of ancient galaxies, and the presence of black holes. The VLA continues a tradition of transformational science that began less than a century ago. Before the 1930s, optical telescopes were the only kind, and astronomers knew little more about the universe than what they could observe with these early tools. Then, in 1932, Carl Jansky made the startling discovery that objects in space also emit radio waves. Since then, pioneers with ever more complex instruments have pushed the science forward, bringing the invisible universe into sharp focus. Since its completion in 1980, the VLA has been making astounding discoveries, from water ice on Mercury to the remarkable jets of elliptical galaxies and the physics behind gamma-ray bursts, the most powerful explosions in the known universe. 50 miles east of the array lies the Rio Grande Valley and the old Spanish missionary town of Socorro. The telescope's scientific center is located here, far from the cold and wind of the high desert. Inside, astronomers uncover the latest chapters in the story of the cosmos.
As an astronomer, I spend a lot of my time sitting at my desk in front of a computer. And while we get observations from telescopes like the VLA, most of the time is spent reducing that data, analyzing that data, and trying to figure out what's going on.
Out of the vast reaches of space, many astronomers find objects that can become career-long fascinations.
Henneis 210 is visible in the south, and it's in the constellation Pyxis, and it's about 30 million light years away. It's a very small little galaxy, but it's a hotspot for star formation. There are these young, massive star clusters forming today, and these are similar to the types of clusters that were formed back in the early universe.
Henneis 210 is 10 times farther away than the most distant object we can see with the naked eye. But in astronomical terms, this dwarf galaxy is our neighbor. Its closely held secrets have been shrouded by dust and gas, but radio light can escape and can be captured by the VLA. On Earth, this extremely weak light must be distinguished from thousands of other man-made sources of radio interference. In a custom-built test chamber, VLA engineers measure the impact of radio interference given off by even the most everyday devices.
Check what we're seeing on the spectrum analyzer screen. Oh, yes. So you can see we're getting some really strong RFI here in the 2.4 to 2.5 gigahertz range.
Even with no service, the radio emission from a cell phone next to an antenna is some 20 trillion times stronger than the most powerful radio source in deep space. Miles away from the safety of the lab, another crew is about to undertake a more daunting task. 30 feet above each antenna's dish is a structure called the apex. Every few months, personnel climb the thin beams to reach the apex for critical installation and maintenance of the VLA's P-band receivers. With gusting winds and difficult footing, harnesses are a must. Only the smallest crew members can squeeze into the apex itself. As the crew works, the rest of the array is still making observations.
Go ahead. Yeah, can you give us color code for the RCP, LCP?
These low-band receivers are especially important for detecting invisible hydrogen gas in the early universe, the main ingredient of future stars and galaxies. Regular upgrades like this are crucial to keep the telescope functioning at the level required by astronomers. But the entire array has also recently undergone a complete reinvention on a massive scale. After decades of stunning science, the 1980 vintage VLA was in danger of becoming obsolete. Without the resources to construct a new instrument from scratch, NRAO devised a strategy to rebuild the telescope from the inside out.
We were able to conceive of a plan that would keep all the antennas the same, keep the rail tracks, keep the infrastructure that supports this instrument, but completely rebuild the electronics.
Over the course of a decade, crews have worked to replace nearly all of the technology inside the telescope, creating a new instrument within its original skeleton. At the center of the VLA expansion project is the development of a new supercomputer called the Correlator. In a meticulously controlled clean room environment, this incredible machine, contributed by Canada, turns 27 radio dishes into one gigantic telescope. Huge data streams from each antenna are fed to the telescope's control building, where the correlator increases the telescope's capabilities more than 2,000-fold. After a 10-year effort, the reinvention of the VLA is finally complete. To integrate the newly upgraded antenna with the rest of the array, the telescope's maintenance crew must perform another vital task high on the desert plains in an intricate dance between man and machine. Not only do the VLA's antennas move to track objects in the sky, they also move throughout the array itself, on the backs of custom-built antenna transporters. Engineers maneuver these 90-ton flatbed locomotives underneath the antenna's triangular base. 230 tons of steel and sensitive electronics is hoisted into the air, and the 94-foot-tall structure is slowly unveiled. The antenna's sheer size makes transporting it a potential hazard. The crew cannot move antennas in winds of more than 20 miles per hour. And maximum speed is just under 5 miles an hour. The array is crisscrossed by more than 40 miles of railway lines. The antennas are moved along tracks that lead 13 miles out from the center of the array to 72 separate antenna stations. These stations are connected to the main track by perpendicular spurs. When the transporter reaches the desired station, engineers use hydraulic jacks to pick up its wheel trucks independently and rotate them 90 degrees to make the turn. They carefully set the structure down, and the upgraded antenna makes its new home in the vast array. About every 4 months, the antennas are moved into one of 4 different configurations, A through D. Each configuration changes the depth and detail the telescope sees. Combining data from all 4 configurations delivers the best image quality. When the antennas are packed together in the D configuration, the telescope can see faintly glowing clouds of gas. When they are at their farthest distance from each other in the A configuration, they reveal the finest details of the radio universe. Now, with antennas fully spread out, the VLA is finally ready to observe the dwarf galaxy Henneis 210. The world's most storied radio telescope prepares to once again open its eyes on the universe.
Copy that. We're getting ready to run the C-band observation.
The antennas turn toward the southern sky. In the darkness above, the light that left Henneis 210 some 30 million years ago finally approaches our Earth. It has traveled more than 150 quintillion miles and persevered through gas and dust to share its secret. The VLA's dishes lock onto the faint beam of light coming from Henneis 210. The radio emissions flood the telescope. And for a few short hours, 2 distant realms share a fleeting connection. An entirely new catalog of human knowledge is captured and recorded. And this 21st century astronomical instrument plays its part in a human journey that began many ages ago. After 6 hours, the telescope moves on to a different target. But the secrets from the distant galaxy have been saved on a microscopic scale. Like messages in an ancient language, they must be deciphered.
Our team just finished reducing all of our new data, and we have some spectacular images now. And we can do a very detailed comparison between the optical data from the Hubble Space Telescope, the infrared data from the Hubble Space Telescope, and now the radio data from the VLA.
The VLA observations reveal a tantalizing discovery.
We found this source of radio emission that looked very much like it might be a supermassive black hole in this tiny little galaxy.
Deep in this dwarf galaxy, less than 30 times smaller than our Milky Way, a hulking giant is feeding on the surrounding gas.
This has implications for our understanding of the evolution of galaxies and their black holes, and even the formation of the first black holes back in the early universe. The VLA data here is really crucial for this discovery, and it would not have happened without it.
This shows a globe of that area, showing the activity, everything we're going to talk about.
Discoveries like those unveiled by Henneis 210 are being made with increasing frequency as astronomers make use of ever more powerful instruments.
On the upper right, we have Centaurus A.
With its expanded capabilities, the VLA promises to serve humanity into the next generation and beyond.
Let's count how many there are. 1, 2, 3, 4, 5, 6. Yes, ma'am. are 28 of the VLAs.
Very good. There are 28 dishes or antennas.
And on this windswept plain in New Mexico, the seed of tomorrow's revelations is already being planted. As a new age looks up on the sky and wonders.
I believe all mankind has that innate desire to know the origins of his being.
Astronomers from all over the world want to use the VLA to uncover the secrets of the universe.
We are adding more and more to our understanding of the universe. You don't have to be a scientist to be thrilled by that.
We've always had the night sky to look at, to ask questions about, and to wonder why it looks the way it does.
Why is it that the Earth happens to be the place where humanity has grown up? What is special about that? And the only way you can understand that is by looking at other stars, other solar systems.
The iron that's in your blood, the calcium that's in your teeth, all those things were made inside those stars.
The good thing about astronomy is that it's not just something to make profit, but it's something that actually might lift the spirits of everyone.
You know, for me, astronomy has to be a part of any civilized society, like music or art.
But I think it's very important to be always asking questions. So I hope that coming to VLA inspires people to ask themselves questions.